This question is asking you to identify the number of stereoisomers that exist for this structure. Typically, we count up the number of stereocenters, typically chiral centers, plug it in this formula for n, and get 2 to the n equals the maximum possible number of stereoisomers. In this case, we've got a chiral center here. He's got 4 different groups. Another one here, 4 different groups. But this guy having 3 identical H's does not have 4 different groups. This guy's a CH2. He's got 2 identical H's, not 4 different groups. And then we've got the alkene carbons, which are never chiral centers. But we'll see here, even though they're not chiral centers, they are the other type of stereocenter, where you can have different stereoisomers cis and trans around a double bond. In this case, had we not noticed that the alkene could be cis and trans, we might have just taken our 2 chiral centers, plugged them into this formula, and got 2 to the second power equals 4. That would be a maximum possible number of stereoisomers. You don't hit that maximum if a meso compound is possible, but we've got no symmetry here, so no meso possible, and we get 4. But we've got to realize with the double bond here, this carbon's got 2 different groups, a hydrogen and a bromine. The other carbon here has got 2 different groups, a hydrogen and then this big carbon chain. So, and as a result, this double bond is capable of cis-trans isomerism. So we'd actually get 4 cis isomers, and then we get 4 with the trans isomer around the double bond, for a grand total of 8 stereoisomers in this case. The other way we could approach this is actually we could have said that there's a stereocenter associated with an alkene that can be cis and trans, and so we actually should have said that there are 3 stereocenters and got 2 to the third equals 8 stereoisomers.